So let's look at a second example of related rates. This one will involve geometry. So in this question, we are asked to find the rate of change of the circumference of a circle whenever the radius of the circle is decreasing. So as we look at a circle, we know that if the circle is going to decrease in radius, then also that circumference would shrink too, because the circle is getting smaller. So let's look at our picture of our circle. And what's the radius of this circle? Now, it might be tempting to say that the radius is 5 inches, but that 5 inches is not a fixed amount. So we can't label this radius with 5. We have to label it instead as a variable, so we'll call the radius r. Now, the circumference of our circle is given by a formula, circumference equals 2 pi r. Now you'll notice that this particular equation does relate circumference and radius, which are the two quantities that we want to discuss, the radius and the circumference. Now we can go ahead and differentiate both sides, again remembering that this is a differentiation with respect to time. So, differentiating the left-hand side with respect to time, I simply get the rate of change of the circumference with respect to time. Now the right-hand side, if I differentiate with respect to time, I have the derivative of 2 pi r. Now you might be able to skip this step and just go ahead and write the derivative of the right-hand side. But I like Leibniz notation here to help us understand what's going on. So this 2 pi is a constant. So that constant factor can be brought outside the derivative. So we have 2 pi, and then we have the derivative of r with respect to t. Now that we have our equation that relates our rates, dc dt and dr dt, let's look at our specific scenario. Now with this scenario, we know that the radius is decreasing at a rate of 0.25 inches per minute. So this tells us about dr dt. So what is dr dt? It might be tempting to write that this is 0.25. But remember that it's also decreasing. And if a rate is decreasing, we can mark it with a negative. So let's go back to our equation. We now know dc dt equals 2 pi, and we know dr dt is negative 0.25. So this means that r dc dt is negative pi over 2. So let's go ahead and write our answer in the form of a sentence. The circumference is decreasing at a rate of pi over 2. Now what are the units? dc, that's the change in the circumference. That will be measured in inches. And time, the change in time will be measured in minute. So therefore, we have, again, inches per minute. So where did the sign go? Why don't I have a negative pi over 2 inches? And that negative has been absorbed into this word. So that's our answer. The circumference is decreasing at a rate of pi over 2 inches per minute.